Imagine receiving a letter that began its journey before Earth existed. A message written not in words, but in light. For billions of years, these ancient photons crossed an expanding universe, traveling through darkness, surviving collisions with gas clouds, escaping the gravity of galaxies, and racing through the void toward a destination they could never know. That destination was us. Every night, when astronomers point their telescopes toward the sky, they are not simply looking across distance. They are looking backward through time. The farther we see, the older the light becomes. A star 1,000 light-years away appears as it existed 1,000 years ago. A galaxy 1 billion light-years away reveals itself as it was 1 billion years in the past. In astronomy, distance and time are the same thing. And no instrument in human history has traveled farther into the past than the James Webb Space Telescope. Positioned nearly 1.5 million kilometers from Earth, Webb was designed to answer one of humanity's oldest questions. What did the universe look like in the beginning? Scientists expected to witness the first fragile structures emerging from cosmic darkness. Tiny galaxies. Primitive stars. Chaotic clouds of gas. The earliest steps of a universe still learning how to build itself. But what Webb discovered would challenge some of our deepest assumptions about cosmic history. Because the young universe wasn't behaving the way it was supposed to. To understand why, we must go back nearly 14 billion years. Back to a moment when space, time, matter, and energy were compressed into a state beyond anything modern physics can fully explain. The event we call the Big Bang. The beginning of everything we know. In the first fraction of a second, the universe expanded at unimaginable speed. Temperatures exceeded anything found inside stars. Particles emerged. Energy transformed into matter. And the cosmic clock began to tick. As expansion continued, the universe cooled. Hydrogen and helium formed. The first atoms appeared. Yet despite the presence of matter, there was no light. No stars. No galaxies. No planets. Only darkness. Scientists call this period the Cosmic Dark Ages. A vast era stretching millions of years. A universe waiting for gravity to begin its work. Slowly, tiny fluctuations in matter grew larger. Invisible seeds planted in the aftermath of creation. Gravity pulled gas together. Clouds collapsed. Temperatures rose. And eventually, the first stars ignited. For the first time, light returned to the cosmos. Those stars became the architects of everything that followed. Inside their cores, simple elements fused into heavier ones. Carbon. Oxygen. Nitrogen. Iron. The ingredients that would one day form planets, oceans, and life itself. According to every major model of cosmology, this process should have taken time. A lot of time. The first galaxies were expected to be small. Disordered. Chaotic. The universe should have looked primitive. Like the rough sketch of a masterpiece not yet completed. But when Webb opened its golden eye and stared into the deepest reaches of space, the universe revealed something entirely different. And what it saw left astronomers questioning whether our timeline of cosmic evolution is missing something profound. When the first images from the James Webb Space Telescope arrived, astronomers expected confirmation. Instead, they found questions. The deeper Webb looked into space, the further it looked back in time. Some of the galaxies it observed existed less than 500 million years after the Big Bang. In cosmic terms, that is almost the beginning. Scientists anticipated seeing small collections of young stars. Irregular shapes. Simple structures. The earliest building blocks of future galaxies. But that isn't what appeared. Many of these ancient galaxies seemed surprisingly mature. Some were far larger than expected. Others appeared densely packed with stars. A few displayed organized structures that looked astonishingly familiar, as though they had already undergone billions of years of evolution. It was like opening a history book to the first chapter and finding a fully developed civilization already standing. The discovery created an immediate problem. According to existing models, there simply shouldn't have been enough time. Stars need time to form. Galaxies need time to grow. Black holes need time to accumulate mass. Yet the universe seemed to have skipped several steps. Astronomers began checking everything. The instruments. The calculations. The distances. Perhaps the measurements were wrong. Perhaps the galaxies were closer than they appeared. But observation after observation told the same story. The ancient galaxies were real. And they were arriving far earlier than expected. Then the mystery deepened. By analyzing the light from these distant objects, scientists could determine their chemical composition. Every element leaves a unique fingerprint in light. A cosmic barcode revealing what stars and galaxies are made of. The results were astonishing. Many of these early galaxies already contained significant amounts of heavy elements. Carbon, oxygen, nitrogen, even iron. That shouldn't have been possible. These elements are not produced during the Big Bang. They are forged inside stars. When massive stars die, they explode as supernovas, scattering heavy elements into space. New stars then form from that enriched material. The process requires generations of stellar birth and death. A cycle that takes time. Yet somehow, the young universe had already completed much of that work. The implication was unsettling. Perhaps stars formed far more rapidly than expected. Perhaps the first galaxies evolved with incredible efficiency. Or perhaps something important is missing from our understanding of cosmic history. Then Webb uncovered another surprise. Hidden within the ancient darkness were enormous black holes. Not ordinary black holes. Supermassive black holes. Some appeared to contain millions or even billions of times the mass of our Sun. These cosmic giants are usually thought to grow gradually over vast periods of time. Yet here they were. Existing when the universe was still in its infancy. Imagine finding a giant oak tree moments after planting a seed. That is how strange these discoveries appeared. Scientists proposed new explanations. Maybe the first black holes formed directly from massive clouds of collapsing gas. Maybe they merged rapidly in crowded regions of the young universe. Maybe unknown processes accelerated their growth. But so far, no single explanation solves every mystery. And the questions continue to multiply. The shapes of these galaxies present another challenge. The early universe should have been turbulent, violent, chaotic. Matter was still gathering. Galaxies were still forming. Yet many objects observed by Webb appear remarkably organized. Some show rotating structures. Others possess bright central cores. Several display a level of symmetry that seems difficult to explain. It's as though order emerged long before anyone expected. Why? No one knows. One possibility involves one of the greatest mysteries in science. Dark matter. An invisible substance believed to make up most of the universe's mass. We cannot see it directly. It emits no light. Reflects no light. Absorbs no light. Yet its gravitational influence shapes galaxies and clusters across the cosmos. Some researchers now wonder whether dark matter played a far greater role in the universe's early development. Perhaps it acted as a hidden framework, a cosmic scaffold guiding ordinary matter into place. If true, dark matter may have helped create structure far earlier than current theories predict. But even that may not be the most profound discovery. Because Webb has also detected complex organic molecules drifting through distant regions of space. Molecules containing carbon, the fundamental ingredient